welcome to yet another video on our channel Euclid Mathematics. We have started lecture series on our ring theory because of CSIR NET SET exam is coming closer. So we have to prepare each and every topic in detail along with some of the examples. So here in my today's video, I will explain to you all one of the important topic from ring theory, which is a subring. So let's get started our today's lecture. Here in our definition of a subring, what is mean by subring? Okay, first of all, the definition of a subgroup. Okay, subgroup already we learn in our group theory, that we need to know first of all. Okay, so if you wanted to understand the definition of subgroup and everything, you just check my previous video. Okay, so I explained there in detail. Okay, but in my today's video, I will just go through some of the only oral concepts. Okay, subring means a non-empty subset. We need to have first of all a non-empty subset, yes, under addition dot, and is said to be a subring of R. Okay, so when we said that yes, under addition dot is a subring of our ring R. Okay, when we have two conditions. That first condition, it says that if A belongs to S, B belongs to S, their subtraction also goes to S. Okay, so it represents the subgroup. Okay, we have same property in subgroup too. And if A belongs to S and B belongs to S, their dot product also goes to S. Okay, so if we take any element from our subring S, okay, any two element, their subtraction also goes to in that subring, and their product also goes to in a subring. Okay, and we know that every subgroup is a subring. Okay, but every subring need not be a subgroup. Okay, so there are some counter exam too, but first of all, try to understand some of the example using our definition, then we'll go for counter example that can prove that property you highlight. Okay, every subring need not be subgroup. Okay, so yes, under addition dot is the ring itself. Okay, so let's get started our today's example. Okay, so which is solely based on the subring definition of a subring. Okay, so here I consider matrix M and R. So M to R matrix is there, which is a 2 by 2 matrix. Okay, and we have to prove that whether this matrix is a subring or not. Okay, so A0 C0 such that it is a 2 by 2 matrix which is from M to R, and AC which is from ring. Okay, and we have to show that S is a subring of M to R. Okay, so we have M to R, and always remember, if you wanted to prove the subring, so we need to know two elements from our ring. Okay, so if you have two elements from the ring, then we can easily show that the subring. Okay, that means A minus B and A dot B, that two elements having subtraction and multiplication is in our subring. Okay, so take that two elements. Okay, so M to R. Okay, we have these two element which is a non-zero. Okay, so by using our definition, we have to show that S is a non-empty. Okay, S is a non-empty. It is not here as a non-zero. It is a non-empty. Non-empty means we need some elements inside S. Okay, so we have possibility A0 C0. This is non-empty subring. But what happens if we have 0 0? Okay, when we have 0 0, we also say that it is a non-empty because some elements are there. They are having some values here 0 0. They are not like a non-empty. Okay, so 0 0 also it is from S, and we say that S is a non-empty. Okay, and which is from M to R. Okay, now let's figure it out, the two property which is A minus B, it is goes to subring, and A into B also goes to subring. Okay, now first I consider A as a A1 C1 0 0 which is from S, and again consider B as a A2 C2 0 0 which is from ES. Okay, so A1 C1 is goes to ring, and A2 C2 also we have to take it from the ring. So here we can see that we have A2 C2. I consider B element as here. So we can see A minus B. So if we go through the subtraction, how we subtract two matrix, we go through some corresponding element subtraction. Okay, so A1 minus A2, C1 minus C2, 0 minus 0, 0 minus 0. This is the corresponding element subtraction in our ring. Okay, so A minus B, the A1 minus A2, it is also goes to a ring, and C1 minus C2 also goes to ring. Okay, so first property of a subring it hold here, and second property of subring it says that we want their product A dot B. Okay, A10 C10 A20 C20, their product A1 A20 C1 C20 also it goes to subring. Okay, so it is easier to show that it can hold the property of subring. Okay, so yes, under addition dot we say that it is a subring of M to R. Okay, now let's see one more example. We will see that whether it is a subring or not. Okay, so here in my second example, I have given here second M to R, second subring B000, and B belongs to integer. Okay, is a subring of M to Z or not. Okay, so we have to show that it is under Z. Okay, under integer it is subring or not. Okay, so M to Z, having the element type A, B, C, D, okay, and A, B, C, D it is from Z, and 0, 0, 0, 0 it is from yes, that means it is a non-empty subset of M2Z, okay. So that means we have all the element which is a non-empty, okay. So that means the element which is inside yes which is a non-empty. So yes is a non-empty subset of M2Z. Okay, now take the two elements and show that these two elements hold both property. Okay, so like I consider here A1 0 0 0 and A1 from yes, A1 from Z. Similarly B A2 0 0 0 and A2 from Z. Okay, and find out their subtraction and multiplication. So subtraction it goes to A1 minus A2 0 0, which is from our subring yes, and A1 minus A2 it goes to 0. Okay, Z. So our first property it hold for our subring, and second property their dot product, we go through the dot product as a row into column multiplication. Okay, so we got the A1 A2 0 0, okay, which is also goes to our subring. So that means the first property of subring and second property of the subring which hold here. Then we say that yes under addition dot is a subring of M2 Z. Okay. And now let us see one more question which is from CSIR NET question paper. Okay. This question asked in previous year CSIR NET question paper, and that we have to figure it out only whether this subring or not under M2Z. Okay. So yes, which is equal to 0 B 0 0 B belongs to R is a subring of M2Z or not. Okay. So we know that we always have non-empty element in a yes. Okay, 0 0 0 0 it is from yes, and which is a non-empty subset of our subring. Okay, which is a M2R. Okay. Now let's take the two element and prove it out whether it is a subring or not. Okay. So it is this one element. So A12 it is a non-zero element. So consider the two element which is A12 having non-zero element. Okay. So 0B1 0 0 0B2 0 0 and B are non-zero here. So A minus B, so A minus B and A dot B. Let's figure it out A minus B. So A minus B corresponding subtraction B1 minus B2. It is also goes to our subring, and B1 B2 from real our ring. Okay. So first property hold here for subring, and similarly second property A dot B. Okay, take that their dot product, will get the 0 0, which is also goes to subring. Okay, we know that 0 0 is a non-empty elements from our subring. Okay, so this is also in a subring, so we can say that yes under addition dot is a subring of M2R. Okay, so these are the very quite easy examples. Okay, just we have to apply the definition of a subring, which is of first A dot B need to be in a subring, and A dot A minus B need to be in a subring, where A and B from our ring. Okay, so I have one more example for you all for your homework. You may try it for your homework. Okay, so can we show that 0B 0 0 and B non-zero, which is belongs to our ring, is a subring of M2R or not? Okay, so we have to show that whether it is subring or not. Okay, let's do it for your homework. Okay, and let me know your answer in a comment section whether it is subring or not. Okay, and if not subring, then why not, and if it is a subring, then why it is subring. Okay, so I will tell you the answer in my next lecture. So this is only for our today's lecture. Just we have to find out the subring it is possessive for our ring or not. Okay, so in my first session we learn here the definition of a subring, then we applied that definition in some basic examples, and at the end of our lecture we learn one of the question which is from CSIR NET exam. Okay, which is solely based on subring topic. So this is only for our today's lecture. So thank you everyone, thank you for my today's lecture.